Hello, everyone. I'm Tom Ballard, the Groundwater Guy, and welcome to Groundwater Talk live for March 31st, 2022. Boy, the year is getting away from us already, but thanks for joining us. One of the fun things about doing this show is the opportunity to meet people in the groundwater business from the United States and all over the world, and through a variety of means. And my guest today is Shahab Hashemi, PhD. I met him on LinkedIn. We've exchanged some information. He's an interesting guy, and he agreed to come on the show. He's got a couple things he's going to talk about today. The main topic is going to be groundwater extraction-induced subsidence in the Varamin Plain in Iran, and I'll show you where that is in just a little bit. And he wrote a paper on that, and so he's got a presentation here. He's also got a lot of what they do is well rehabilitation. So he's going to talk a little bit also about some innovative well rehabilitation techniques as well as part of his presentation. So I'm really looking forward to this. It's like I say, he's an interesting guy, and it's just awesome to have him on the show. Before we get going, though, if you can drop a hi in the chat and let me know you're here or a comment, I'm more than happy to see you out there. I like to know that people are there, so just say hi if you will, and I appreciate that. All right, so by way of introduction here, and unfortunately, we ran a test run on this, and his internet connection where he's at in Iran right now is not very good. So I recorded an audio introduction, and then what he did is he sent me a presentation. So we're going to see a recorded presentation. The live just did not work. We just didn't have a good enough internet connection, but it's still an interesting presentation, and I'll let you know how you can get a hold of him when we get down to the end here, and that'll be great. So. By way of introduction, Shahab Hashemi, PhD. He's on LinkedIn. That's where I met him. He is. Let me look at my notes here. The Civil Water Resources Managing Director at Optionat Sanat Energy Limited in Iran, and they also have offices in Canada. They do water well rehabilitation, leak detection, and some other civil engineering things related to water issues. So he's got a lot of background. He is a PhD, so that's above my pay grade. But he's the study he did is pretty interesting. So let me dive into. I did an interview and just got a brief introduction from him. It'll be the audio, and then I'll show you where the study area is, and then we'll dive into the actual presentation from there. Okay, so let's do the intro. Let's talk a little bit about your background too, because that's really important. You're certainly an expert in a number of areas, and I've read through your LinkedIn profile, and obviously we've had some communications, and I certainly think you're an expert, which was why I was interested in getting you to come on the podcast or the show. And so maybe just a little background on your on your history, your education, and your experience.
Okay. Thank you very much. Thank you for your invitation. I am very happy to talk with you in podcast. I am Shahab Hashemi, who is a PhD in water resource management. My education history is this. It is around 20 years that I am managing director of a company which is an EPC contractor. It is ASE Iran company. We have a branch in Canada, and we do many projects in Iran about water losses management and leak detection. And the other part in our company is water well rehabilitation and groundwater management. Our projects about water, groundwater resources started about 7 years before. we are in cooperation and direct contact with TLM company hydropulse method for well rehabilitation, but we use different methods for this. I test these methods, and now we are very happy with this unit, but we have a complete solution for customers. We open some deformation of the water wells with our designed jacks. We open them because of the land movements. We have this problem in Iran many times, and in many wells we have the closed wells. The other one which we work for wells is pumping test. We do it. The other thing which we do is brassing or cleaning with chemicals. But the solution for hydropulse is very, very good, good method in Iran with lots of results which I can share, and they are shared in my LinkedIn profile. I'm very happy and thank you for this, because I understand that you are sharing your experiences with people. We are very happy to do that, and my contact is in last of my presentation, a recorded film. I'm sorry, sometimes this internet is coming and it goes, because we are in Nowruz holidays in Iran for New Year holidays, and internet is not very good. So I will send you the recorded presentation. Sorry for my English. I'm not very good in that, but I try to upgrade my language. Thank you very much.
All right. Well, his English was pretty good to me. So, as a second language, he did quite well. So I had no problem understanding him. So anyway, that's the by way of introduction there. I'm gonna dive into his presentation a little bit, but first off, I wanted to show you the area of his study. It's in the presentation a little bit, but I wanted to give you a little bit wider angle view. So to that, we go to Google Earth, of course, and that's so we're really going to be looking at the Varamin Plain in in Iran. So let's just dive over there and look and see where we're at. I've kind of got it. Let me just zoom out here a little bit. You can see to the north we got Tehran by way of reference. The circle area is the circled area is basically the Varamin Plain. What he's going to be talking about. I didn't take the time to actually outline the entire thing. You'll see that in the presentation. And then Varamin, of course, is the city kind of right in the area. As we dive in a little bit, you can really see he's going to be talking a little bit about the farming, but you can see there's a lot of farmland in here. So there's obvious a lot of irrigation pumping that's going on, and therein lies the source of the problem here. So there's the area we're looking at. If we zoom back out, as point of reference in the world, you can see down south, we have the Persian Gulf here, Saudi Arabia, and then to the north, we have the Caspian Sea up here, and then the Black Sea over here, getting up into Russia up here. But that's where we are in the world as we dive out, and so that's kind of where we're at on things. So let me run the presentation here, and then we'll come back. I think the presentation runs about 25 minutes or so, and then we'll come back after that.
Hello to everybody. I am Shahab Hashemi from Iran. I have experiences on water losses detection and groundwater management in different Iranian projects. Today, I would like to talk about predicting land subsidence based on groundwater level change and using radar interferometry, INSAR technique, and regression statistical equations. It is a case study in Varamin Plain. Okay. Vertical movement of the Earth crust is one of the most important geological phenomena that appears in the form of subsidence and uplift. Numerous reports of land subsidence, especially in arid and low rainfall areas, have been presented, and Iran is no exception due to its location in the arid and low rainfall belt of the world. In this presentation, I am talking about a prediction way of land subsidence based on groundwater level change via using radar interferometry, INSAR technique, and regression statistical equation in Varamin Plain, south of Tehran. If you can see the picture which I'm presenting, one of the most important factors influencing the subsidence phenomenon, which has been studied by many researchers around the world, is the change in water level in different aquifers. For this purpose, Varamin Plain was selected as one of the strategic plains of the Iran in Tehran province. According to the approach of this research, in order to evaluate the change in ground elevation from 2040 to 2019, the radar interferometry technique INSAR was used and satellite images were analyzed by SNAP software. Finally, by evaluating change in aquifer level through observation wells and land surface change in the study area and comparing statistical models, it was found that the linear regression model has a more favorable prediction power than a parabolic regression model, and it is grade 3. In continuous, the change of water level in the next 4 years, from 2019 to 2023, according to the regression model, were predicted in linear ways, and based on that, the rate of land surface change was evaluated. The results showed that, according to the current trend of aquifer decline, the maximum amount of subsidence in the linear model is equal to 266.74 centimeters in the center of Varamin Plain in the coming period. If you can look this picture, it can show that what can cause land subsidence. Land subsidence is a gradual settling or sudden sinking of the Earth's surface, owing the surface movement of Earth materials. The principal cause of land subsidence are aquifer system, compaction, drainage or organic soils, underground mining, hydrocompacting, natural compacting, sinkholes, and thaw permafrost. Subsidence can use and can cause significant change in the hydrology of the region by changing the topographical condition of the region. For example, in these areas, massive and destructive floods may occur while they had no history before. If you can see, the sinkholes here happened because of the land subsidence. Here is another picture which you can see that because of using much groundwater or illegal wells, they cause some problems for the land. Okay, what we do? If you can see in this picture, we do some analysis of trend of change in Varamin aquifer surface according to piezometric data. We take them, and after it, we go to land subsidence and uplift change with Sentinel-1 satellite. After it, we do processing satellite image with the SNAP software. We eliminate effects of orbital and topographical errors after it. We do some mathematical modeling relation between groundwater level and vertical ground movements with SPSS software. And after it, we select the best equation, which was the linear equation. We do some predicting water level change by linear relation over the next 4 years. And after it, GIS map outputs display change and land movements over the next 4 years. This is the area which it can show that in the Iran area, which in the north is Caspian Sea, and in the south you can see Persian Gulf. In Tehran area there is Varamin Plain, which can show you it is a place of agricultural place, and there are many farms there that they use. It is about this catchment is uh, in an area of 1072 square kilometers, located in about uh, 35 and 7 minutes to 35 and 79 minutes north latitude, and 51 degrees and 26 minutes to 51 degrees and 55 minutes east longitude. You can see that average annual temperature in this basin is about 60.9 degrees Celsius, and also average rainfall is around 156 millimeter per year. Also in Varamin aquifer, the number of groundwater level curves varies between 818 and 820. Changes in groundwater level cause change in aquifer, poor water pressure, which also decreases with decreasing water level. Okay, here you can see that we do with Sentinel-1 satellite. Data was used to access subsidence. The image obtained from this satellite are mosaic and interconnected, so that an image consists of different rows, bursts, and columns with the name of IW, which you can see in the figure 3. And based on the study area, part of the image will be selected. After selecting the desired area, the desired section will be analyzed. In next picture, okay, here you can see that we find some places and we do analysis with the snap software, and the colors shows the land movement. Right hand picture is a very famous picture which shows that during 190 to 77, you can see that there is a very high land subsidence in San Jose Valley in California. Okay, now we talk about the snap software, which we do some analysis of earth movements, and you can see that this is a very useful software, and it is free from ISA uh, community, and we use this software for analyzing the land movements. The theoretical of the analysis which we do is here, and you can see in the presentation how we find the phi for movements, and we use fuzzy components including the atmospheric phase The rest of the noise phase is eliminated by errors, and we do some analysis. After this, which it has a very special job. You can do it very easy. We can see that satellite image outputs from SNAP software for Varamin Plain from 2014 to 2019. And these maps can show land movements, which include subsidence and uplift. And after it, we do some simulations and comparisons of vertical change of groundwater level and change, which you can see that the vertical movements of the earth is versus with aquifer level change via graphs in different times during 7 years. We analyze it and find the results. After it, in order to obtain the general relation between the amount of vertical ground motion and change in the aquifer, we use SPSS software. By entering the above information in SPSS software, we find some regression between these, and it shows that grade 3 regression statistical data and a share of this software is here for you to see. In the next slide, we talk about how we do it and what is the equation or formula we find. According to obtained results in table 1, I can tell you that equation number 5 with a very good sign works, and it was lower than half, and shows that this is the formula which can find a relation between land subsidence and recorded level of wells. Okay, here in figure 7, therefore, for this study, the linear model equation 5 was selected as the best model to determine the relationship between land subsidence change and groundwater level change. In this regard, y is equal to the amount of vertical land surface change in Varamin Plain during 2014 until 2015, and the x are also equal to the rate of change in groundwater levels. You can find everything in this map about our analysis. Okay, in this picture you can see the predicted water level change over the next 4 years. After the blue lines, you can see these are our predictions, and the trend of the change in piezometrics shows that the linear function according to the condition is very similar to results which we gained, and it can show us our predictions. And in next slide, which is figure number 9, the final trend of subsidence change in Varamin Plain in the future period according to the optimal linear regression equation between 2019 and 2023 is something like this, which we can see in center we have a very bad situation, and these black holes are our wells which we record their level, and this is a map of what will happen. Varamin Plain is an agriculture place, and the number of the wells and abstraction from the aquifer has greatly increased. And we can see in the pictures I show you in the first slides that the water level in Varamin aquifer has dropped by about 42 meters. The purpose of this study is to investigate the vertical movement of the earth in relation to change in water table in this plain from 2014 to 2019 and predict the exact of these changes in the statistical period of 4 years, which I told you about between 2019 to 2023 by statistical model, and therefore we calculate the amount of displacement in the Earth surface using INSAR radar interferometry techniques, and the necessary filters were used to eliminate all the noises in the satellite image by comparing the regression relations between vertical land surface change and aquifer change from the oscillation of observation wells in the plain and comparing them with each other. The linear regression equation was superior to the third degree and parabolic regression. Finally, according to the results, it has been found that during the linear forecast for aquifer, water level and determination of subsidence values according to the optimal linear equation between subsidence change and water table, the maximum subsidence value in Varamin Plain is equal to minus 266.74 centimeters in next 4 years. It often shows itself in the center of the plain and around urban and agricultural areas. Therefore, it can be concluded that this high subsidence can be due to uncontrolled abstraction of groundwater and reduction of water level in the aquifer. There is also a possibility of digging more illegal wells in the central part of the study area, which we are working to find some illegal wells via recording the level of water with mathematical equations in another project. The suggestion for this area is frequent field visits and additional research to provide effective solutions also in order to prevent land subsidence and the damage caused by its strategies such as rehabilitation projects, preventing the digging of illegal wells and uncontrolled withdrawal of water from them, changing traditional irrigation methods to a new method, modifying the cultivation patterns to the position of product is more compatible with water shortage and the importance of training programs for farmers in the field of modern irrigation method is advised. And after it, modern agriculture methods and the use of advanced tools and facilitates them in agriculture. After it, because of suggestion of Mr. Thomas about our project for water well rehabilitation, because of caring wells and in operation wells, we do some intensive pumping with moving chamber plus hydropulse systems for regeneration or rehabilitation wells or development them to reduce turbidity and a better quality. Here I can show you a clip which we do for this job in our projects. I'm very happy if anyone have a question about water well rehabilitation method, which we use hydropulse units, and we are very happy to do it for projects and do these projects to for better efficiency. You can see here. If you can see here, we are using some suction tools, and we put the pump in a pipe to do intensive pumping here. After it, in this place, we use hydropulse for pulsing and opening slots of the well, and we do some suctions in different points of slots, which you can see the results here. Okay, here you can see the water well rehabilitation and development, which is done by ASE Water Clinic, which we do water well rehabilitation, water well development. We use decreased pumping rate because of these problems. We do water well rehabilitation, decrease water level, decrease specific capacity, increase sand or sediment content in the water, decrease total well depth, or fix the formation and any fallings to the end of the well. I'm very happy to talk with you, my friends, and we are very happy to cooperate with you to reply any questions. And many thanks to Mr. Thomas Ballard about this presentation, which he lets me to do this presentation for you. Thank you very much. Bye bye.
Okay. Thanks so much for Dr. Hashemi to do that presentation for us on the Varamin Plain and also on some of their well rehabilitation techniques. They're working with a hydropulse system which uses compressed nitrogen, if I remember right, and so they're actually doing some good work with that, and As you know, if you followed me at all, well rehabilitation is one of my wheelhouse items, and so I'm always interested in hearing about different applications of the different techniques that are out there and improved efficiencies on well rehabilitation. So appreciate that. So he put a link in there, so there's a URL in there for ASC waterclinic.ca. That's their Canada office. You can also reach Dr. Hashemi on LinkedIn, which is where I originally connected with him. He's got a LinkedIn page, and you can see he's got over 500 connections there. And so here is the actual URL to his LinkedIn page, and I would urge you to connect with him and get some more information because he's pretty knowledgeable. And as you can see with the study he did in the Varamin Plain, he knows how to use a lot of the different techniques. The Sentinel imagery is satellite imagery is the European Space Agency version of Landsat, and it's actually in a lot of senses it can be better imagery than Landsat in a lot of ways. So if you're not familiar with Sentinel imagery and you're doing anything with high altitude imagery, I'd urge you to look at that. So there's definitely a good point there. So anyway. That is Dr. Hashemi's information. I thank him very much for doing the presentation for us. I found it informative, and I hope you did too. Let's kind of wrap things up here, and we're here every week, of course, from on Thursdays, 9 a.m. Pacific time, 11 a.m. Central time, or the equivalent of wherever you are in the world. You can reach me at tballard@groundwaterguy.com, and I'm more than happy to hear from you. If you got any suggestions about shows or any specific comments, drop me a line. I'm always happy to hear from you. So we stream into the Groundwater Guy YouTube channel, so you can find us there. Some people like watching us on YouTube better than LinkedIn, but I'm also on LinkedIn, so we simultaneously stream to both those places using a restream that allows us to do that at the same time. And so you got the option. All our past videos are all stored on the Groundwater Guy YouTube channel, and I try to link to those on my LinkedIn profile as well. But they're all there on the Groundwater Guy YouTube channel, and we've got a lot of interesting stuff, pretty varied. So I'd urge you to check that out. If you're interested in being a guest on the show, here's the link. You can email me, or you can go to our Book Me link, and this gets you there to come on. And if you've got a topic of interest to the general groundwater community, water resources managers, water system managers, hydrogeologists, engineers, we're more than happy to have you on if it's a interesting groundwater topic. If you look at the past shows, we've kind of been all over the place on that, and so whatever's interesting and informative to people, we're definitely interested in that. So come on the show. We'd love to hear from you. So thanks so much for watching. Don't forget to subscribe to the Groundwater Guy YouTube channel. And there's yep. Thanks, Steve, for tuning in. And once again, subscribe, hit the bell if you want to know when we got new videos coming up. But once again, every Thursday, we will look forward to seeing you next week.